Hello, my name is Elfrida. If you couldn't tell by my face or know who I am, that's who I am. And today I'm going to talk about the stellar cycle of stars. So basically, the life span of a star and what a star goes through. I'm gonna shrink myself in the tiniest little corner, and then I'm gonna show you guys the slideshow. But without further ado, let's get started. So, first steps. Stars always come, well, not always, but they stem from stellar nurseries. So stars are born in stellar nurseries known as stellar nebulas or nebulae. They are clouds of gas and dust, and gravity pulls them together. They clump them together and they come together like a little group. And as the groups grow, their gravity increases, which causes them to heat up. And so, I got some cute little nebulae on the screen. Nebulas? I don't know. But that last one right there is the Cat Eye Nebula. So, yeah, pretty cool. Actually being a star, depending on how the star converts hydrogen into helium in its core, so stellar fusion, it decides on where they are in the HR diagram. So if they're main sequence, low mass, a brown dwarf, or stars that wanted to be stars but aren't really stars, or really massive stars, really freaking huge, O-type class stars. This decides their spectral class or their temperature and how long they live. So, if you have a really big star, like the blue star that I'm showing right now, you are going to die. I'm just kidding. Well, you die quicker. Every star dies, but this one just dies quicker. But if you're a main sequence star, then we can talk about being old and being more evolved. So depending on where the star is on the HR diagram, they could die early in their life, like super hot stars, like the blue star I was just talking about, or if they're a stable star, they're likely to turn into a red giant or a super red giant. So Betelgeuse, take Betelgeuse for an example. They think that was a main sequence star, but it is so evolved later on in its life that it just becomes it's just huge. It's literally just a huge red star. So that's why it's so bright, and even though it's cool, yeah. Main sequence stars turn into red giants when they come off of the main sequence. So when they're you got the little you got the little loop. Main sequence is this little line. Red giants is right here. You know what I'm talking about? Yeah. That's when they become a red giant. White dwarfs, nebulae, and supernovas. So depending on the mass of the star, it will either evolve into a white dwarf, a planetary nebula, or die and go supernova. So white dwarfs are the corpse of a star, and they're still burning really hot, but they're so small, so they're not even bright. So a white dwarf, usually their color is white. So this is the type A stars. White dwarfs are essentially little things still giving off heat. We're just looking at a corpse of a star. That's what a white dwarf is. Nebulae. The star runs out of fuel and sheds its outer layers, so the gas expands into space, often forming a ring or bubble shape. The star's core becomes a white dwarf. So, like I said, white dwarfs. The white dwarf's ultraviolet radiation illuminates the gas, causing it to glow. So it's these really big, beautiful paintings, take M42, the Orion Nebula. That is, I believe, no, that's a stellar nursery, but you get the idea. It's just a bunch of gas that's radiating all over, and it's being illuminated by a white dwarf. So that's pretty cool. And a supernova. When the core of a massive star collapses, it could be a neutron star or a huge explosion. The energy released by this core collapse is converted into a type 1b, type 1c, or type 2 supernova. So those are a bunch of just different supernova. Type 2s usually have pulsar stars, which are neutron stars, just with a bunch of radiation being vomited out by their poles on their axis. Anyways, speaking of that, let's talk about black holes and pulsars. So in rare situations, supernova remnants can collapse on themselves and squish together all of their little atoms into dense little objects like neutron stars and black holes. Neutron stars can also turn into pulsar stars, where they spit out radiation from both sides of the star's poles on its axis. So it's like, I don't have a ball. We're gonna use this. So this is a little star, and she's, doing her thing. She's moving around, collecting, stuff. Then it turns into a pulsar star. So it has like, or depending on where its axis is, you'd be like this, or like this, like all over the place. But it comes from the two poles of the neutron star's axis. So that's pretty cool. Sometimes I think that I'm a neutron star because I can burp and fart at the same time, but that's too much. That's gross. Sorry. Anyways, but yeah. That is essentially the stellar life cycle. Depending on where you are in the HR diagram, stars can just go white dwarf and then turn into a nebula, or their nebula can be squished and squanched together after existing for so long, and become a black hole, or so depending on how massive the star is, so how heavy it is, it could either end up as a white dwarf or a nebula or a supernova. Big old stars usually go supernova, and those are the prettiest ones ever. I think they're really pretty. Deuces.